नमस्ते प्रोफेसर सिंह। इसमें मेरा थोड़ा वीडियो ठीक से नहीं आ रहा है, मैं दूसरे सिस्टम से ज्वाइन करता हूँ, एक मिनट। मृदुलः, भवान् श्रूयते वा?
आं महोदय।
अस्तु, अहं सिस्टम् परिवर्तनं कृतवान्। अस्तु,
अस्तु
स्पीकर अपना फोन नहीं उठा रहा है, सरप्राइजिंग है। वेट करते हैं 2 मिनट।
अस्तु।
सः शीघ्रं जायिन् करोति। नमो नमः रामनाथन महोदय।
नमो नमः अनिल महोदय।
भवतः कैमरा एकवारम् आन् करोतु। नमो नमः, महान् सन्तोषः। सो
6:15 or 6:30 do we start?
we'll start at 6:15.
6:15, okay.
Actually, vacation, long weekend. So many students went home and multiple events are happening as part of this Azadi Ka Amrit Mahotsav. Some people are joining through YouTube also. मृदुलः आरम्भं करोतु।
अस्तु महोदय।
सर्वेभ्यो नमो नमः। आदरणीयाः मान्यवराः मम प्रियमित्राणि च अहं तन्वी प्राचीनकालात् मध्ययुगपर्यन्तं रसायनशास्त्रे भौतिकविज्ञाने च भारतस्य वैज्ञानिकपरम्पराम् उपरि व्याख्यानकार्यक्रमे अस्मिन् सायङ्काले भवतां सर्वेषां स्वागतं करोमि। अस्मिन् वार्तायां वयं रसायनशास्त्रे, भौतिकशास्त्रे, धातुविज्ञाने च भारतस्य अद्भुतवैज्ञानिक साधनानां केचन प्रमुखविशेषताः कलाकृतीनां माध्यमेन पश्यामः, तथा च इतिहासलेखनस्य अभावेपि कालपरीक्षायां जीविताः समृद्धग्रन्थाः अपि प्रकाशयिष्यामः। अस्य कार्यक्रमस्य विशिष्टतिथिः श्री वी रामनाथन महोदय, प्राध्यापकः भौतिकरसायनशास्त्रज्ञः वर्तते। लेजर स्पेक्ट्रोस्कोपी, रमन माइक्रोस्कोपी, कंप्यूटेशनल रसायनशास्त्रं च प्रशिक्षितः अस्ति। तस्य वर्तमानां शोधं जीवविज्ञाने, चिकित्साशास्त्रे च रमन स्कैटरिंग, रमन इमेजिंग प्रयोगे च केन्द्रितम् अस्ति। अहं रामनाथन महोदयं सम्प्रार्थये निवेदयामि, कृपया अस्मान् प्रबोधयतु।
धन्यवादः। प्रथमतया मम संस्कृतं त्रुटिपूर्णमेव, तत्कारणात् अहम् आङ्ग्लभाषायै अयं वक्तव्यं वक्तुमिच्छामि। So please, the due apologies to all the Sanskritists here, because I don't want to end up butchering the language with my faulty Sanskrit. So I'll continue with यथा अहं मैकाले मानसपुत्रः अस्मि, तदैव आङ्ग्लभाषायै अहम् अयं व्याख्यान वक्तुम् इच्छामि। So first of all, thank you for having invited me for this beautiful lecture. As a lecture, the beautiful organization of a Sanskrit week. I really congratulate IIT Roorkee and specifically Professor Anil Gaurishetty for taking lead in organizing this. Very hearty thanks to you and the entire Sanskrit Club team of IIT Roorkee for having this kind of a program. It's always a good idea to begin this program, any program, with an invocation. And I too would like to have an invocation for this. So just give me a minute. One second, I'm just trying to get one file up. This being a talk of chemistry, I specifically would like to begin with this invocation. I'm trying to pull up the wordings of that. ओम श्री गुरुभ्यो नमः। हरि ओम। अश्मा च मे मृत्तिका च मे गिरयश्च मे पर्वताश्च मे सिकदाश्च मे वनस्पतयश्च मे हिरण्यं च मे यश्च मे सीसं च मे त्रपुश्च मे श्यामं च मे लोहं च मे अग्निश्च म आपश्च मे वीरुधश्च म ओषधयश्च मे कृष्णपच्यं च मे कृष्णपच्यं च मे ग्राम्याश्च मे पशव आरण्याश्च यज्ञेन कल्पन्तां वित्तं च मे वित्तिश्च मे भूतं च मे भूतिश्च मे वसु च मे वसतिश्च मे कर्म च मे शक्तिश्च मे अर्थश्च मे एमश्च मे इतिश्च मे गतिश्च मे. So with that invocatory verse, I would like to begin my lecture. And for that, I have prepared a presentation which I would like to share. I hope my presentation is visible in the full view.
Yes, Mahodaya. It is visible.
Presentation mode, I hope it's visible.
No, not yet. Yes, now it is in presentation mode, Mahodaya.
Okay, good. So, yeah, this is the next 50 minutes or so. I'll briefly take you through this journey of our country's scientific heritage, specifically in chemistry and material science from ancient to medieval times. I'm sure Professor Michel Danino and other illustrious speakers would have covered the other scientific heritage, and the mathematical heritage of our country is indeed very well known to most of the people. But heritage in chemistry and material science is something that I'm interested in this aspect, and I'll be presenting to you, giving you a bird's eye view, a Garudavalokana of this material, for which I've divided my talk into following bullet heads, where I would like to briefly comment on Vigyan and science, and then in the crux of Indian epistemology, wherein what is our approach and impetus to this quote unquote, the word that we normally use called science. Then of course I'll be getting into the glimpses of the Indian chemistry, material science, metallurgy, and briefly telling you about the prominent literature overview with a few examples. What's the style with which literature pertaining to these topics are normally written? And of course, ideological bias in the historiography when these texts were relooked in the last 100 years. Now, the word Vijnana, be it in Sanskrit or any of the Indian languages, is a very commonplace. It's not that it's a very special word. And one of the earliest occurrences that we come across for this usage of this word Vijnana is in this Taittiriya Upanishad, where of course there is in the Shikshavalli of the Taittiriya Upanishad, where you have this Annamaya, Pranamaya, Manomaya, Vijnanamaya, and Anandamaya. The Taittiriya Upanishad is of course divided into three: Shikshavalli, Anandavalli, and Bhriguvalli. And like I always tend to compare this, the pedagogic style of school learning, high school learning, or college learning, and then research. Because in Shiksha, there are only various instructions are given. In Anandavalli, certain abstract definitions are given. And in Bhriguvalli, which is the pinnacle of this Upanishad, we come across the pedagogic style of research, explore and find out. And again, another pedagogic structure we come across here is that it's a conversation between the Guru and the Shishya. And in the case of the Bhriguvalli, it's a conversation between Bhrigu and Varuna, who happens to be the Guru and Shishya, and also father and son, where Bhrigur Vaiva Runihi Varunam Pitaram Upasasara. That's how that Adhyaya starts, where he says he found, looking at the question basically asked was Adhi hi Bhagavo Brahmeti. What is this? That is the entity called Brahman. Then the Guru says, Tapasa Brahma Vijijñāsasva. You do tapas, you do the penance and find out what this Brahman is. Like the typical, the module of research that we are all familiar with. Now this fellow goes, the Shishya goes and he finds out, comes back and says, Annam Brahmeti Vyajanat, Annadhyeva Khal Bhimani Bhutani Jayante, so on and so forth, he says. And then like a typical research supervisor, the Guru does not say yes, does not say no. He still says, Tapasa Brahma Vijijñāsasva Tapo Brahmeti, Satapo Tapyata Satapas Taptva. Like that, he says, the Guru says, okay, fine, you will find out for yourself when you do the tapa. So like that, when they go, there is a particular verse where at a stage where we come across the term Vijnanamaya. He says, Vijnanam Brahmeti Vyajanat. So, like that, the crux, the point that I'm trying to drive home here is the word Vijnana has been in our parlance from a very ancient time. I don't want to attach a particular date to this Upanishad, but it suffices to say it's from a very antique period that we are familiar with the term Vijnana. Now, in normal Sanskrit, how do we understand the word Vijnana? Vishesha Jnanam iti Vijnana. So that was somehow to the Western science that it was imported in our country. The word Vijnana was used for this. Now that has got stuck in all the Indian languages also. Now, whenever we talk about Vigyan today, this allusion to our age-old relationship with this word Vigyan somehow takes a back seat, and it is a Western science that comes to the mind. And I find it a little bit derogatory because that gives a sense as though before this import of Western science, we did not have any scientific rigor or scientific thought or scientific output in our country. So this is a personal remark with which I wish to open up this my talk, because all that I'm going to present is again hardcore science, may not be in the language with which we understood, we are able to understand that past science. Okay. I mean, there's a very beautiful lecture by Professor Balakrishnan from IIT Madras, which is available in YouTube, Thaumaturgy in the Age of Science, where he also says that if Isaac Newton were to come today, it will be very difficult for him to even understand the modern technology. But given the sharp brain that he had, he would eventually be able to understand it. So the language with which even science gets practiced, propagated, and communicated varies over a period of time. It's a very dynamic process. Okay. So yeah, I will stop my the introductory remark was to drive home the point that it's not that the Western import of science made all our people oriented towards Vijnana. There has been Vijnana in our culture from a very old time. And as I said, the language may be different. And secondly, all the Vidya that we were either generating or propagating, it was all aimed towards an esoteric goal. You take up any of the Shastric quotations, Adama Dhanamichanti, Dhanamanam tu Madhyama, Uttama Manamichanti Manohim Hatandhanam. We have always attributed the highest pedestal for mana or the knowledge. Like that's why it is said, Shraddhavan Labate Jnanam Tatpara Samyatendriya Jnanam Labdva Param Shanti Achirenadi Gachati. Or even if it is be in this case, Savidya Ya Vimuktaye. It is for that is one type of Vidya that which was oriented. The other kind of the Vidya or when these Vidyas were written for a specific subject, compartmentalized within so-called some of the subjects per se, they also had a very specific objective. For instance, this is a Rasaratna Samuchaya. I have taken a quote from there, which happens to be a chemistry text. The third line of this shloka goes, Prabhaktanam Prabhava Prasamghat Kritija Raraga Roga Kshanak Shantihi. The basic purpose of this text is to make the Roga Shanti. So you had certain utilitarian aspects for the Vidya and you had a very esoteric objective for the Vidya. So these two were going hand in hand, and we find the impact or the effect or the utility of these Vidyas through these texts. So coming to the contributions of past Indians or the ancient Indians and medieval Indians, and from chemistry and material science or metallurgy, the contributions are indeed varied and they are diversified. For instance, in metals, minerals, gunpowder, ceramic, medicine, mordant dyes and pigments, cosmetics, paints. This is just very illustrative, limited list that I have shown here, but the list is not exhaustive. And today we have, as I said, linguistically coined several terms and have intellectually put them in certain compartments, but the past Indian contribution are in these many varied fields. often a criticism is also laid that all these science, or particularly in respect to chemistry, materials, or metallurgy, that were developed were indeed empirical or serendipitous. That is, you did not have a theoretical framework with which the science or this chemistry was developed, like what we teach or what we learn about the Western European chemistry, that you have a law of mass action, then you had certain basic Boyle's law, Charles' law, a theoretical framework with which a subject developed. That's often a criticism given to the Indian science in general, but more so for subjects like chemistry, because we do not, apparently we do not get to see a theoretical framework. This is where I would like to urge our interesting audiences who are listening to refer to the work of Brajendranath Sheel, who was in fact a contemporary but senior to Acharya Prafulla Chandra Ray, whose birthday we had the good fortune to celebrate just 10 days back on August 2nd. Brajendranath Sheel had written a very beautiful book called The Positive Sciences of the Ancient Hindus, where he has argued, he has put forth the theoretical framework under which all our sciences had worked, had developed, had even created knowledge. And in fact, the communications also that used to happen had a theoretical framework. So I'll not bother the audiences with much more minor details, academic details about those theoretical framework, but it suffices for me to say that lo and behold, the theoretical framework does exist, and it is only the matter of our open, we being open to read these theoretical framework and kind of relate them to the science that they were practicing or the science that it emanated from. So for just give you a glimpse of the kind of this is the content page of from this book that I've taken. So for instance, if you look at this doctrine of scientific method, what we normally attribute to Karl Popper or to some extent even Occam's through the Occam's razor, all the Western philosopher under which the scientific Western scientific truth is based, we do have counterparts in the Indian literature who predate to Karl Popper or Occam by several centuries. So, say for instance, this is how Brajendranath Sheel puts forth those factors here. Observation and experiment, results in different sciences, fallacies of observation, doctrine of inference, the Charavaka view, the Buddhist and their analysis, so on and so forth. So this is just to impress upon you the fact or the joint method of difference, Panchakarani, the proof of the method, doubt and its limit. So I'm sure if any of the modern science student with a little bit knowledge of Sanskrit, and of course my my illustrious audience who are listening to me from the Sanskrit Club in IIT Roorkee, if you happen to go through this text, you can immediately make out the relationship with the original verse that Brajendranath Sheel is quoting, and I'm sure this will add value to the kind of information that you are interested in about the Indian science. Now, there was a reason for which I began the invocatory verse, because that is from the Krishna Yajurveda, it is Chamaka Prashna, 5th Aruvaka, where this line specifically comes. Hiranyam chame, ayaschame, sisam chame, trapuchame, shyamam chame, and lohan chame. So there are mention of 6 distinct metals in this verse, namely Hiranya, Aya, Sisa, Trapu, Shyama, and Loha. Now there are different opinions by historians of science who have interpreted Hiranya to be silver and Aya to be gold. And Panchanan Niyogi was also contemporary of Prafulla Chandra Ray, who has to his credit 2 very authoritative monographs on copper and iron, had interpreted Hiranya as silver and Aya as gold. Much to the contrarian view of his own contemporaries and current historians of science, and the way we understand today, Hiranya to be gold and Aya to be iron. So, in fact, linguistically, people have even traced the IR to be cognate with the English word iron, IRON. And that's a very interesting argument, linguistic argument that people have produced. But I wanted my audience to also be aware of such kind of fallacies that one can come across while reading the literature about our ancient chemistry. So there are copious mentions of materials, but we do find mention of 6 distinct metals right from the Vedic lore. Just because these 6 metals are present in this Anuvaka of Krishna Yajurveda, it shouldn't give the audience an impression that the mention of metals starts only from here. No, there is a story that finds its mention in the Rig Veda. Now, assuming that the Rig Veda predates or is antiquated with Yajurveda, there is a story in Rig Veda where there's a mention of one Vishphala who loses. She's presented as a female warrior who fights in the battlefield, and while fighting she loses her leg, and then there is a prosthetic leg given to her which is made of iron. Now there are some commentators who have interpreted Vishphala as a horse, and there are some commentators who have interpreted Vishphala as a female warrior. So be that as it may, there is a mention of iron leg even in the Rig Veda. And of course there are mentions of gold, silver, copious mentions of them even in the Rig Veda. What I wanted to impress upon you is there is another series of verse that gets published in 1927, and by far I would say this is the last kind of that classical literature getting generated in our country, and after which at least to the best of my knowledge, we do not have this kind of literature being generated. And the last of them was Sri Bhudev Mukherjee, who was an Ayurved. He was a Vaidya from the province of Bengal, and he had written a text called Rasa Jala Nidhi in style of the previous acharyas of the Rasa Shastra like Nagarjuna, Vagbhata, so on and so forth. He writes the Rasa Jala Nidhi, in which also he mentions a group of certain metals, Swarna Tararka Lahuncha, Yashodatra Pusisakam, Saptaitani cha Lohani Shuddhani Kshiti Mandale. So he, besides the 6 metals, he adds actually one more metal, and that is the of mercury. So we can see the continuity of perception of metals right from the Vedic age to say 20th century, early 20th century, where our association or our intellectual foray has been quite aligned. It's not, what I'm trying to say is it's not that there's a sporadic intellectual spurt at some point of time and then we are only singing glory of that one spurt all throughout our life. It's not that. There has been a continuous association. That's literal evidence is what I'm trying to give you here. So coming to specific metals, like for instance, gold, if you take, gold happens to be a very interesting metal, and across all the civilization, across the world, not just Indians, one of the early metals that was not just venerated or given the highest value, it was also worked in large copious quantities, was gold. And as I said, India is not just an exception, but if you look at the composition of our Earth's crust, the crust is that second layer that we see beneath the water. Then you have the mantle, then outer core and inner core. And here I'm giving you the distance which they span. So below 100 kilometers, the crust starts, and the crust goes for about 670 kilometers. And whatever excavations or extractions of metals that human history has happened, it has happened between this 700 kilometers. Very rarely goes to the mantle. And of course, that's a modern technology. But in the ancient, you cannot think of going beyond the crust. And if you look at the abundance of the Earth's crust, it's near about 75% is silicon and oxygen. And remaining 25% is distributed, and major of them being aluminum, iron. And you can see here, gold is within this small minuscule component, which is 0.2%. So you can see the abundance of it, and that's why this is one of the cherished metals. And you had such one-to-one association of our culture with the gold, that you find frequent mentions of it in the Rig Veda. Example of it that I've given you here. Just a moment, yeah. Okay. So, besides the mention, this is from the Rig Veda. Now, as I said, let's not get into the debate of dating the scripts. But if you look at different manuscripts from different points in time, one of the manuscripts that falls later is Arthashastra, where an entire chapter is devoted for processing the gold. How it should be assayed, how it should be measured, how its purity should be tested, who is qualified, what should be the qualification of the gold inspector, so on and so forth. So for Kautilya to describe in such detail about the gold, and Arthashastra being a document of polity, or it's like a custom document. Even today, if you go to a customs document, if you come across some document pertaining to customs office, we will see a lot of, or say specifically with respect to narcotics, there is a lot of chemistry described in it. So it not only reflects the knowledge of the then society about those substances, but it also talks about the law and the enforcement in place for organizing the society. So the fact that Kautilya includes a whole chapter upon gold, we can clearly imagine to what extent the technology of processing gold, handling gold, using gold was prevalent in the society back then. Now, talking about the literature, giving you a style of literature that was written, it really pains me a lot as a student of chemistry that we were not told about this right in our school days. What is it that I'm talking about? This is a verse taken from the 4th chapter of a chemistry text called Rasaranava. And sadly, we do not know who the author of this text is. And like any text of our past, the error bars of the dating ranges within few centuries. So Rasaranava is dated anywhere between 800 to 1200 century after the Common Era. So you can imagine there are 400 years of range. I do not think any other text in the world would have this large error bar when it comes to the dating of either our scholars or the works of these scholars. Be that as it may. This is a shloka which starts like Avartamane Kanake Pita Tare Sita Samaprabha Shulve Nila Nibha Tikshne Krishna Varna Sureshwari Vange Jwala Kapotabha Nage Malindhumaka Shailetu Dhumara Devi Ayame Kapila Prabha. So by now the knowledge people who are knowledgeable in Sanskrit would have made out what this shloka actually means and why I am pained as a student of chemistry. This talks about actually flame test. And to the best of my knowledge, in the entire world, this is the first text which distinctly talks about what should be what change the flame color undergoes when a particular metal is introduced to the flame. This is what even we today do in our high school in the name of flame test. If only our students are also told about this is such a thing is described in our text 1000 years back, it would add to their knowledge and of course develop a sense of pride in our own past. And slight digression here, I think within the ambit of NEP 2020, brighter days are ahead where we could think of including such kind of materials also. And thanks to such events like Sanskrit Club of your IIT, we are getting to talk about these in public forum in a much more open and diverse manner. The glimpse of the style of writing in in our literature, again from Rasaranava, Navispulingo Nachabudbudascha Yadana Rekha Patalamna Shabdaha Mushagatam Ratna Samam Sthirascha Tada Vishuddham Pravadanti Loham. So there is a process of how to purify a metal, in this case a loha, which is iron, is covered in this chapter. This is 52nd shloka, which means 50. Before this, all the process would have been defined. Why I'm specifically showing you this is you see how qualitatively the author makes a quality check Now he's pulling over, and the translation goes like this. A pure metal is that which, when melted in a crucible, does not give off sparks, nor bubbles, nor spurts, nor emits any sound, nor shows any line on the surface, but it's tranquil like a gem. So you don't, of course, today we have, say for instance, SEM or even other advanced microscopic techniques to find out what are occluded metals or what are occluded impurities in the metals, to find the microstructure and what occlusions have happened to the microstructure. With the lack of such kind of advanced techniques, 1,000 years back, our forefathers devised qualitative checks to assure the purity of the metal which was subjected to purification. One example is that I have shared with you now about iron. So here, one of the famous or the most widely read historians of science, Professor A.K. Biswas, in his essay, which was published by the National Metallurgical Laboratory, Jamshedpur, on metallurgy in India, he has this particular paragraph which really impressed me. This is about copper ores. And there are three different types of copper ores: Makshika, Vimala, and Sashyaka. Now, A.K. Biswas observes it, and I completely opine with him, which I would like to all my audience to appreciate, that our ancients knew that Makshika is different in appearance from Vimala, and they both are different in appearance from Sasyaka, because their physical appearance is very different, because they are of different. One could be an oxide, one could be a carbonate, one could be some other salt. Their appearance are indeed very different. But the ingenuity of our ancients is that they knew that when subject to the specific processing, Samshodhana Kriya, all these ultimately lead up to copper, tamra. This knowledge they knew, be it Makshika, be it Vimala, or be it Sasyaka, they knew that if I subject them to the specific Shuddhikarana, they will lead to the ultimate metal, which is tamra. So here, this is where A.K. Biswas kind of thinks aloud through this writing, that this is a reductionism that they are already known. And he says, I quote him, that this observation made centuries before the discovery of elements and Daltonian chemistry cannot be belittled. And he further goes on to say, perhaps this is, if this is not the knowledge about the atomic copper, then what else could it be? They did not use the term, terminology was different, but the understanding was indeed there. Gold and silver, of course, our ingenuity to work with gold continues to this day, and in the form of the Banarasi jari. Banarasi silk is not produced in Banaras, it is the thread, the golden thread work that is still in vogue. And this is not something that is of a recent past origin or a gift from some of our invaders. There are continuous mentions of this, and not get into the details of that due to want of time. Not just the gold, Banarasi jari work is one such example. You also get to see the classical temples. Some of the classical temples which are still functional, but sadly most of them are only situated in southern India today. But be that as it may, at least there we have certain functional temples where we get to see the temple, the jewelries that Bhagavan or Devi or the Devata adorns during festival seasons. And there we get to see the glimpse of how the gold was specifically, gold and silver were processed, and what were the age-old designs. So this would give us an idea. At this juncture, I would also like to mention, re-mention about the Arthashastra. In that whole chapter on devoted to gold, there are subsections which clearly says, if you want to make a necklace where you have a hollow gold tube, how to go about it. Solid gold necklace ornament, how to go about it. Bangles, hollow gold tube and golden bangles, or a solid bangle, how to test them. if it is a hollow and it is kind of mixed with or filled with some kind of adulterant, how to detect that. So those kind of things are also mentioned in Arthashastra. People interested can go through them. I'll not spend the point that really impresses me as a student of chemistry is that this is from Arthashastra, that chapter I've taken. Sreshthanam Pandashvetam tadyena apraptakam tat chaturgunena sisena shodhayet sisanvayena vidyamanam shushkapadalai madhyar apayet rukshatvad vidyamanam tailagomayet nishechayet. So this is a process which is being described, and Arthashastra Kauntilya describes it. Okay. It's about purifying gold, and there is actually a solid state reaction which is getting discussed. Now, today we understand the alloys of gold from the terminology of what we call the phase diagram, where we say in what temperature, and in this case it is the alloy with copper. Otherwise, gold has got a tendency to get alloyed with copper, with zinc, with various metals, with silver, with of course with mercury it forms an amalgam. But one such simpler phase diagram is with copper, and that's what I'm trying to show you here. I don't want to give an impression to my audience saying that our ancestors had the knowledge of phase diagram. No. Phase diagram is a modern construct. Today we understand the formation of alloys through the phase diagram. But what I'm trying to impress upon you the fact is that they knew, perhaps empirically, different phases or different compositions of gold and copper, because the kind of ornaments that they produced varied in their physical texture and properties. So they knew how to control the formation of these alloys. That they knew, but not from the point of view of phase diagram. This is the reverse engineering that we are trying to do today. As a matter of fact, why I'm saying this is, even if you go today to the shop, to the gold shop, even if in a third tier town, the kasauti stone or the touchstone on which the jeweler tests the gold, that practice is something that has continued for a long time. One of the technologies, sustainable technologies, if we talk about this testing gold on the gold stone, is one such thing from our country, where very quickly the jeweler can make out with the counterfeit or how much of real gold is present in it. So this, to take a crystallized practice in a society, needs accumulated knowledge over a period of long time. Okay, so I will not dwell deeper into that about the silver part. This is about the silver, how many different types of silver are produced. Again from the Rasarnava. Again, the impression that I'm trying to give you is that all these activities are not just a spurt of genius at one particular point in time. We find it continuity. This is called the Theva art of Rajasthan, where very fine filigree of silver are made and they are placed on glass. The history of Theva art may be 300, 400 years, but a community or the practice has been in different forms over a period of time. Among the metals, if gold and silver was ubiquitous and spread across the civilization, one such metal which we could really be proud of complete monopoly and control over the entire world, was this zinc. Okay? And world over, the Indians are indeed praised about it. But then some of the historiographers have had a different kind of a comment. One such, even Acharya Prafulla Chandra Ray is not an exception in this, because he was of the opinion that zinc was introduced to India through the Chinese route, through the trade between the two countries. Of course, he has been proved wrong by various methods, and one such refutation is what I'm trying to show here, presented by, again, Professor Bishwas, who in this essay, that the reference that I've given, he has refuted, he has shown how Acharya Prafulla Chandra Ray was in fact wrong to harbor this kind of a belief that zinc was introduced to us. Lo and behold, if this was P.C. Ray in the early 19th century, we had Professor B.V. Subbarayappa in the 60s carrying forth a similar argument that zinc was introduced to India from China, but there are ample evidences today that this is proved wrong. India was indeed, zinc was for the very first time processed, smelted in our country, processed and imported outside. What did Hindu chemists know about the zinc? Of course, the name also is very interesting. In Chinese, it is Tutanag. In fact, in Tamil, the word for zinc is Tuttanagam. And Tuttanag is also a term present in the Ayurvedic or the Sanskrit literature as well. Coming to the other terms for zinc, it's very interesting. And the Hindi, it is still carried forth as Jasta or Jasta, because the other term for zinc in Sanskrit is Yashada or Jashada, with Yajayor Abheda, because it is Yashada, because it is as lustrous as silver. That's why the name was given to it as Yashada. And because you have Ya and Ja Abheda, some portions of it is also called, some people also call it as Jashada. Again, quoting from Bishwas, now it is accepted that India was the first to make metal zinc. Again, the Rasaka is also a very interesting term here. By the distillation process as practiced for the other metal, mercury. Because the process by which the zinc was obtained was more or less similar to the process by which mercury was processed, the name Rasaka was added to zinc. The ancient Persians tried in vain to reduce zinc oxide in an open furnace, and the Jhavar or near the Udaipur are archaeologically proved hotbed for the zinc metallurgy, zinc smelting, and even to this day there are reports of zinc mining from this place. I'll not get into this. This is all the linguistic argument on why the zinc comes into picture. I'll not get into that. So yeah. Importantly, why zinc? Even today, smelting or obtaining zinc is not a trivial process. It's a very, very sophisticated method, because the melting point as well as the vaporizing point of zinc is much, much lower compared to other metals. Okay, so you needed special techniques handle, because just as and when the metal comes out of the ore in a liquid form, it immediately has a tendency to vaporize, and then if you are not able to capture back the vapors and condense them to the liquid form, you lose the metal. So the technique or the technology is quite unique, and this is how the processing happens. That you have a pot, which is of course empty, and that is buried beneath the ground, and you have another pot of similar shape and size, which is inverted on the top of it, and then there is a kind of a preparation that separates between the two. Then you have this top jar filled with the ores of zinc, and you put the fuel to fire up outside, which is above the ground. So it is heated from the top, and as the mercury is forming, as I said, it forms a liquid and then it immediately forms a vapor. Those vapors have no ways to escape out but to percolate downwards. And because it is the pot below is buried beneath the ground, there's a huge temperature gradients, and as it meets a lower temperature, the vapor immediately condenses. And there is at the end of the process where the entire vapor has condensed, then there is a sealing happens also. And after the process has ceased, the next day or following several hours, when the flame has gone out, they will cut open this and dig open the bottom jar to get the liquid zinc. And this gave them nearly 100% pure zinc. Okay. No, the dating of it is also very interesting. We do not find zinc before, say, for instance, 8th century. And all the texts which talk about the zinc also, which before, say, 8th century, for instance, say Nagarjuna's Rasaratnakara, does not talk about explicitly about the zinc. But before zinc, it was known, brass and bronze were indeed known. So brass and bronze are alloys of copper with tin and zinc. So that was known not just in India but in various parts of the country. But the beauty is that, again, from the phase diagram point of view, there were different ways of preparing the bronze. But elsewhere, the different ways is to control the amount of zinc in the copper. So nowhere in the world they could find bronze which was more than perhaps 20% zinc. It was only in India and especially the northern India and around the Zawar belt, where people have excavated artifacts which contain more than 30% of zinc. And there are again technically the different ways of producing that alloy, and I'll not get into that. But and again, this is not something serendipitous or accidentally described. They discovered. They had the proper control of temperature by which they could produce artifacts of bronze by varying amount of zinc, and that alloying process happening at different temperatures. I request the organizers to prompt me about the remaining time because I see I've consumed 45 minutes.
Yeah, you can go for 5 more minutes. It's okay.
Okay.
Yeah, thank you.
So these are the current excavated remains from the Jhavar, pictures of them. Now you can see the Vrintaka Musha. Incidentally, this is called the Vrintaka Musha, or the retort with inverted shape, or the retort in the shape of a brinjal. Those you can see here, excavated remains, which we find them even to this day. And this is the work by Craddock, who is known as was the ace archaeometallurgist. He says the scale of production Jhavar was enormous. The many hundreds of thousands of tons of debris suggest the production of many tens of thousands of tons of zinc. Okay, so the mammoth, the gigantic amount of zinc that was produced is something incomprehensible. Many tens of thousands of tons of zinc, and it is also categorically now shown that the earliest dated zinc mines in the world are the Jhavarmala mines from the Udaipur belt at Rajasthan. And it is indeed now believed that the present remains at the Jhavar are the earliest known center of zinc production on an industrial scale. About the text, yeah, one thing again about the style of the text which I wish to draw your attention to. This is again from Rasaratna Samuchaya this time, where there is the entire text is like a conversation between Bhairav and Bhairavi, and this is the 4th chapter, and that's how the 4th chapter begins. Sri Devya Vacha Yantra Mushatni Manani Najñatva Mantra Vedyapi Kim Karoti Mahadeva Tani Me Vaktum Arhasi. So we can get the purport of this shloka here. She says, Yantra Musha Agnimanani Natnyatva Kim Karoti Tatkaranad Eva Bhavan Vaktum Arhasi Kim Vaktum Arhasi Yantra Musha Agnimanani Tad Vishaye Kimchil Vaktum Arhasi Va. So Kim Karoti Kevalam Mantra Vedyapi Aham केवल मंत्र वेद्यपि हम किम करोति हम किम करोमि. So you look at the attitude with which the chapter begins, because the first 3 chapters are about what should be the qualification of the chemistry student, what should be the qualification of the guru, what a mantra vidya happens, how a laboratory should be established. Now how the laboratory should be established comes in this chapter, but before that all was theoretical stuff. Now she says, what will I do with just the theoretical stuff? I would like to know about the practical aspects. Okay, so here that's what the Sri Bhairava Vacha. Then he says, Mrinmayani cha yatrani mushphalo lukhalani cha. So he'll say, I'm going to talk to you about the various apparatus that are being used in this chapter. So that's how this chapter talks about the different kind of apparatus that even now some of the apparatus that we use today in industrial scale or even in laboratories. For instance, this is called a Tiryak Patana Yantra, where sublimation. So this is specifically for purifying mercury from its mercurous salt. And this was also practiced or used by P.C. Ray to produce one of his very famous mercurous salt, for which he is known as the king of nitrites, mercury nitrites. And this is called the Shvedani Yantra, Patana Yantra. This is the Tiryak Patana Yantra, which is again used in perfumery industry to extract the perfumes from various flowers, which are used even today. If you go to Kannauj, which is called the perfume capital of our country, it is still being used, and this were in continuous use even before the invaders had given, because there is a big argument which is being produced is that the Mughals had given us some of the perfumery technology, itr, through the word. Be that as it itr may be their word. I'm not saying they did not have the perfume technology, no, but our perfume technology was a continuous process. And when there was Tiryak Patana Yantra described in a text much centuries before the Mughal invasion, how can we just say that the perfumery came only through Mughal invasion? So that's the one point which I wanted to drive home through this year. Okay, the various, one element of here, the knowledge of reactivity. For instance, here you see in this sloka, Suvarnam, Rajatam, Tamram, Tikshnam, Vangam, Bhujangamam, Lohantu Shadvidam Tacha Yatha Purvam, Tad Akshayam. So this is arrangement of the metals in the orders by which they decay, or the orders by which they do not decay, Akshaya. Suvarnam, Rajatam. So this is the order: gold, silver, copper, iron, tin, and lead. These are the 6 metals and their resistance to rusting. Of course, they got something wrong here, because lead, tin, and iron it should be, not the iron, tin, and lead. This we understand from modern electrochemistry. But what I'm trying to say is, without such detailed analysis, even they could also arrange these metals through various experimentations and come to this kind of a conclusion. My perhaps last comment here. Of course, I have certain things to show, but the pedagogic, how do we write the text today, vis-a-vis how the texts were written, say, long back. This is a very famous story. Sanskritists may very well know about the Samasya Purti. One such Samasya Purti, because this is Sanskrit club, I can discuss Samasya Purti in detail. Yes, so the Samasya is Pipilika Dantivaram Prasuti. Pipilika Dantivaram Prasuti. There is a Samasya. The Samasya Purti goes like this. Kakhadanti Bhumigatan Manushyan Pipilika. Kimhanti Simha Prakata Prabhavaha Dantivaram. Karoti Kimva Paripurna Garbha Prasuti. Pipilika Dantivaram Prasuti. That's how Samasya Purti happens. But why I'm connecting that with this is, see, the knowledge of a child who is learning even chemistry, he should know that the lion establishes its prabhutva only by killing the elephant. Otherwise, elephant is one of the mightiest animal, and the lion can also kill the elephant only if the lion approaches the elephant from the backside. Okay. Now, why I'm narrating this is, in the same text, we come across this shloka. Naso asti loha matango yamna gandhaka kesari nihantyad gandhamatrena yadva makshika kesari. There exists no elephantine metal which cannot be subdued by the lion-like sulfur. So what the author wants to say, I have a sulfur which can react to any metal, no matter how powerful that metal is. That's why this imagery is used. So just imagine the kind of the pedagogic structure that the author has employed to convey the beautiful message that sulfur is a highly reactive element, and that is a unit of reactivity with which we measure the reactivities of other metals. So even today, this is an inspiration for those textbook writers who, instead of making the subject very dry, can make use of imageries and adopt such kind of creative pedagogic structure, and called cross-disciplinary learning, which again the NEP 2020 talks about, can very effectively be brought through such very beautiful examples. These are all part of some of the works which we try to do in our lab. I'll spare you with that because of want of time. Just to impress upon you the fact is that all the texts or the processes that we say are very much doable even now. Just language is different. Say, for instance, one of the Vedi, for instance, they would say use these many cow dung cakes of this dimension. That's all they would have mentioned. But that's to control the temperature. So today we can measure using thermocouples the temperature. So one such thermocouple measurement was that if you use the maximum temperature attained were different in different cases. So that was something to impress upon you from our work, but I will not bother you with that. I'll quickly skip this and perhaps come to a close of what I wanted to say. Continued legacy, I've already commented about. Now, my very famous quotation and very famous thing with which I would like to conclude, that this was C.V. Raman, who was invited by Rutherford in Cambridge, and C.V. Raman goes across the Cambridge and comes back and comments to Rutherford, and I quote, "It seems to me Cambridge is a place for play and not for study." Because C.V. Raman saw students doing all sorts of things, jumping around, playing around, handling things, working with things and stuff like that. Prompt came the reply from Rutherford, who said, I quote, "We do not try to grow bookworms here. We train men who can govern an empire." So today we are generating perhaps bookworms, but with such infusion of our past knowledge, where we generated knowledge for knowledge's sake and for our practical utility to solve our immediate problems, I'm sure perhaps we would also be aiming at generating or creating people who could govern an empire and not just bookworms. With that, I thank once again the organizers and particularly Dr. Anil Gauri Shetty, for giving me this wonderful opportunity to share a few thoughts of mine on Indian chemistry and material science with one and all. Thank you. If you have any question, I'll be happy to, if I'm able to answer, I'll be able to answer, and I'll be happy to interact. Thank you. Dhanyavad.
Uttamam Mahoday, if anyone has any question, she can either paste it on chat box or raise his hand. Pratigya sir, you can unmute yourself and ask the question.
नमो नमः महोदय। अहम् आयुर्वेदग्रन्थेषु अगाधतन्त्र इति टॉक्सिकोलॉजी विषये पठितवान्। अन्यग्रन्थेषु अपि टॉक्सिकोलॉजी विषये वदति वा अन्यथा न? Do we have any reference of toxicology apart from Ayurvedic text or
in Rasaratna Samuchaya as well as in Rasarnava, there is a chapter dedicated to this. All the why the chemistry texts were written, first of all, those were the texts to help Vaidya to make the drugs. Okay? So invariably, all these, at least to the best, I have come across a chapter on toxicology in Rasaratna Samuchaya. Maybe I can show you that. Just give me a minute. I can pull out the content page of Rasaratna Samuchaya. I can show you that. In the meantime, somebody else can ask another question by the time I am pulling out that particular reference.
Anyone with a question? Mahoday, I have a curious question.
Yeah, go ahead.
Many of us talk about like Ashok Stamp and all, but As far as according to my knowledge, we don't know the actual formula of it, how it was made. So
See, the point is, when it comes to, that's why I showed you the phase diagram also. Now, iron phase diagram is also very complicated. It's a very good question. In fact, not just Ashok Stambha, the Woods steel. If you talk about the Woods steel, there is a criticism that, of course, we only exported the iron, and it was in Damascus, in Syria, where the sword was kind of forged. So we did not know the art of forging it because it was not reproducible. From modern metallurgy or chemistry point of view, you should understand that phase diagram is putting understand from phase diagram. Now, if the control of temperature is not very precise, you will not be in a position to get it every time reproducible. Now, with respect to steel, what happens is, if there is more than 4% of carbon in iron, it will become a different kind of a iron. So to produce high quality of steel, you require near 4% of carbon. If it is too less, again, it becomes too brittle. If it is too high, again, it becomes too problematic. So it's a technological challenge to control the temperature in a precise manner to produce that alloy of a specific property. That part we must understand. It's a challenge even today with even Celsius controlled ovens to produce alloy of a definite proportion is a challenge even today. So perhaps that's why if you go back in time, it was indeed a challenge for them. And that's why if you see, they would have done lots of trials and errors before. And then they would have got the final product, and that is there for us to see even after a long period of time. So it's not right to say we do not know the composition. The composition indeed is known, formula, everything is known, but it's an inbuilt intrinsic technological challenge to produce them, actually.
You answered.
There is one more question. Lots of historians basically they date these recent advancements in chemical sciences in India as they try to project that these advances were done by Siddhas of Nath Sampradaya mostly. Since they date Nath Sampradaya as from 9 to 13th century BC, so not BCC, so they basically the timeline of recent advancement in chemical sciences does not goes back to BC. So how to counter this argument basically?
Okay, so this is a specific argument, not just chemical science alone. This is about mercury. And it is indeed true that the Nath Sampradaya or the Nath. Now, I have a question to the gentleman who asked this specific question. As a teacher, normally do not answer. You produce one more question to answer that question. Geographically, where do you think this Nath Sampradaya is spread to?
So there are a lot of misconception about that. Some people say it's Maharashtra, some people say it's Himalayan region, and some people say it's Bengal region, starting from the Vajrayana Mahasiddhas. And there are also some proof of southern India also.
Okay.
So lots
Good
of
that you mentioned about the southern India, because today, all said and done, the Tamil counterpart of Ayurveda is Siddha. And in the Ayush, AYUSH, that S stands for Siddha. And those people, the Siddha medicine, they will, the Siddha practitioners will bet for their life about the antiquity of Siddha medicine, Siddha literature also. And if you look at the names of the Siddha, the Navanath Sampradaya, the Nath Sampradaya is exactly followed even in the Siddha, the Tamil Nadu Siddha culture also. Okay.
Satyam.
Coming back to your question, the dating is always a controversial issue in our history. Why to go all the way to Natha? Take, for instance, Nagarjuna. Nagarjuna's date is also not precisely given. He is dated all the way from 400, 4th century BCE to 4th century AD. There is an error bar of almost 500 years with his date. Okay. Secondly, I forgot to mention this caveat in the beginning. So the way today we understand chemistry is, of course, European chemistry. Now, I am not claiming that our ancients knew the law of mass action or the law of thermodynamics to arrive at a particular reaction. They did the reaction and their understanding the language was very different. Today we look at it from this lens. Okay. So it is wrong to say there was no chemical sciences before this particular Nath Sampradaya. It is, I am at least do not subscribe to that argument at all. And your question actually is more relevant to the processing of mercury. And there again, we have enough evidences to show that before even this tantric period, there was some mention about the mercury. But even from Prafulla Chandra Rai, it is believed that the tantric period, which is more obsession with mercury, starts from 8th or 9th century after the Common Era. So it's not generalized about chemical sciences. It is specific about mercury alone. I hope I answered your question.
Yes, thank you.
I'm only trying to look at the somehow in the content page, the toxicology chapter, I have not put it on the slide. But if you look at the content page of Rasaratna Samuchaya, you will find toxicology there also. This was to answer the first question. So yes, reference of toxicology comes in Rasaratna Samuchaya.
Thank you, Professor. Now I would like to invite Head of Chemical Sciences, Professor Uday P. Singh, to deliver a thank you note to Professor V. Ramanathan.
So it's my turn to give the vote of thanks to the today's speaker. इसमें सबसे पहले मैं प्रोफेसर रामनाथन, रसायन विभाग, IIT BHU को वार्षिक संस्कृत सप्ताह समारोह और चल रहे IIT रुड़की के 175वें साल समारोह में व्याख्यान देने के निमंत्रण को स्वीकार करने के लिए धन्यवाद देता हूं। विशेष रूप से महोदय, आपने संस्कृत का क्या रोल है साइंस में, स्पेशली रसायन विज्ञान में और धातु विज्ञान में के बारे में आपने अपने व्याख्यान में बताया, जो कि बहुत ही इंफॉर्मेटिव है। और आपने यह भी बताया कि पुराने समय में कैसे गोल्ड और जिंक को प्यूरिफाई किया जा रहा था। आपका व्याख्यान काफी प्रेरक रहा और इसके लिए आपको बहुत बहुत धन्यवाद। मैं डायरेक्टर IIT रुड़की प्रोफेसर अजीत कुमार चतुर्वेदी को भी धन्यवाद देना चाहता हूं, जो इस तरह की एक्टिविटी को खास करके संस्कृत क्लब के ग्रोथ को आगे बढ़ाने के लिए, इसको प्रमोट करने के लिए सभी सुविधाएं संस्कृत क्लब को प्रदान कर रहे हैं। मैं प्रोफेसर अनिल कुमार गौरी सेठी, जो कि फैकल्टी कोऑर्डिनेटर हैं संस्कृत क्लब के और साथियों एसोसिएट डीन स्टूडेंट्स हैं, उनको धन्यवाद देना चाहता हूं। और उनके हम सब लोग आभारी हैं कि उन्होंने इस तरह का कार्यक्रम कैंपस में आयोजित किया और करते रहते हैं, और मुझे धन्यवाद प्रस्ताव देने का अवसर उन्होंने इस कार्यक्रम में प्रदान किया। इसके अलावा मैं स्टाफ और संस्कृत क्लब के सभी सदस्यों को इस व्याख्यान को आयोजित करने के लिए धन्यवाद देता हूं। लास्ट में मैं उन सभी कर्मचारी, स्टूडेंट्स वो धन्यवाद देना चाहता हूं जो इस क्लब को आगे बढ़ाने के लिए जो है अपना योगदान कैंपस में दे रहे हैं। धन्यवाद।
Thank you, sir, for addressing our guest. Now I would like to invite Shweta to deliver a vote of thanks on behalf of Sanskrit Club.
नमो नमः। आदरणीया गणमान्यजनाः, मम प्रियमित्राणि, अहं श्वेता भारतीय प्रौद्योगिकी संस्थानस्य संस्कृत समूहस्य कार्यकर्ता अस्मि। अस्मिन् द्योतक सायंकाले धन्यवाद प्रस्तावं प्रयच्छन् अहम् आनन्दितोऽस्मि। प्रथमतो अहं डॉक्टर वी रामनाथन महोदयस्य कृते संस्कृत समूहस्य पक्षतः सहृदयं कृतज्ञतां समर्पयामि। यदनेन महोदयेन स्वबहुमूल्यं समयं प्रदाय कार्यक्रमः अयं सफलीकृतः। यत्तेषां सहायेन इदं कार्यं सफलम् अभूत्, एवमेव सर्वेषां कृते अपि अहं हृदयेन धन्यवादम् अर्पयामि यदस्मिन् कार्यक्रमे समुपस्थिता वर्तन्ते। तथा च अहम् आशासे यत् भवन्तो अपि तादृशमेव आनन्दम् अनुभूतवन्तो यथाहं भविष्ये अपि एतादृशेषु कार्यक्रमेषु अत्र सम्मिलिता भविष्यन्ति। श्वः अवधानं कार्यक्रमम् अस्ति। On the occasion of Pragyotsav, tomorrow we have Avadhanam by Dr. Sampadananda Mishra at Bose Auditorium, Physics Department at 5 p.m. Dhanyavadah.
Now I'd like to invite our faculty coordinator, Professor Anil Kumar Gorishetty, to speak a few words on the event.
That's okay. The program is over. Vote of thanks is also done very nicely. So, from faculty coordinator point of view, I sincerely thank Ramanathan Mahodaya. So we are eager looking forward to your physical visit to the campus. I hope we'll make it, for sure in near future. Thank you so much for explaining things in a lucid way. Thank you, Mahodaya. Dhanyavadah. Okay, Bridal, we can close now.
So, Professor Ramanathan, when did you join the chemistry department IIT BHU?
Bridal, you can close the YouTube live. Yeah.
Which year?
2018.
2018. Good. Thank you.
Thank you, Professor Singh. Thanks for spending your time.
Thank you. Thank you.
Okay, so now, Bridal, we can close the meeting.
Punarmilamam, Sarve Namo.
श्वेतकेतवे सुवचलां दत्तवान्। सुवचला श्वेतकेतुः सह धर्मचरी अभवत्। तौ दंपती दीर्घकालं यावत् सुखेन गृहस्थ